Hello class and welcome to Unit 1, Video 4. Today we're going to look at solving compound and absolute value inequalities. So after today you can solve compound, and this should say and absolute value inequalities. Okay, so we're going to look at an example. One test used to determine whether a patient is diabetic is a glucose tolerant test. Patients start the test in a fasting state, meaning they have had no food or drink except water for at least 10 but no more than 16 hours. Write the acceptable number of hours, H, for fasting by using an inequality. Okay, so it says at least 10. Okay, so we're talking about hours. 10, hours 11, 12, 13, 14, 15, and 16. So it can be between 10 and 16 hours, okay? And it can be at least 10, so I can be equal to 10, but no more than 16, okay? So I could be equal to 16. So we know that at least 10, so the hours have to be greater than or equal to 10, and the hours can be no more than 16 hours, so the hours have to be less than or equal to 16. This is what we call a compound inequality, and we can actually rewrite this. If I go ahead and flip this around, if I write 10 first and I flip my sign, it looks like this. Then you notice I could combine these. So I could write this as a compound inequality. Okay, so it's between 10 and 16 hours. This is the way I can combine these two inequalities for one. So this is showing that I can be between 10 and 16 hours. All right, so what is a compound inequality? Okay, compound is joined by the word and or the word or. Okay, so let's look at this first one. The and inequalities are true if and only if both inequalities are true. So here's an example. It says x is greater than or equal to -1. So here's greater than or equal to, so this is a closed circle. Greater than or equal to -1 would be this way. And x is less than 2. Well, I'm not equal to, so open circle. And to be less than 2, I would go to the left. So and is when they are both true. Notice they're both true here. So this in the blue is my final answer, because that's where it's double lined or double shaded, whichever way you want to think about it. Okay, so that's an and inequality. Or our inequalities are true if one or more. So or is just if it's there, that's part of the answer. Okay, so in this case, x is less than or equal to -1. That's drawn here. Or x is greater than 4. So open circle to be greater than to the right. So see how it wasn't double shaded like it was here? So or just means it's just got to be true for one of the statements, and it has to be true for both statements. So we're going to be solving some inequalities. So we want to solve for x and graph the solution on a number line. So looking at this one, we can solve it as one big equation. The only thing is it's got 3 parts. There's the first part, the middle part, and the end part. So what we're going to do is we're going to subtract 7 to solve this equation. And so what we have to do is do it from each part of the inequality. So I have 13 minus 7, which is 6. This will give me is less than 2x is less than 10. Now my last step is to get x by itself. I would divide everything by 2. I didn't divide by a negative, so I don't need to flip my sign. So it's 3 is less than x is less than 5. So there is my solution. When I can write it like this, this is an and statement. Okay, so let's go ahead and graph it. We can really graph it in 2 parts. It's x is greater than 3 and x is less than 5. So my number line okay, I'm going to do my work up here, and then my final answer will be on my number line. So x is greater than 3, so we're not equal to, so open circle, and to be greater than, I'd be going to the right. X is less than 5, so not equal to once again, to the left. Now my final answer I'm going to put on my line. Notice it's an open circle, so it's not included here, but it is included here. So they both have to be true, so they're both not true, so open circle. It's not double here, so no answer over here. It's double here all the way up to 5. Once again, I'm going to have open circle and shade in between. So my final answer is listed on this number line here. Okay. right, let's move on to example B. I would recommend that you pause the video and do B on your own, and then come on back. So hopefully you've had time to pause the video. I'm going to go ahead and add 4 first. So I have 12 is less than or equal to 3x is less than, this will give me 15. Now I would divide each piece by 3 to get x by itself. So I have 4 is less than or equal to x is less than 5. So once again, I'm going to graph it. I'm going to take less steps than I did last time. So I'm going to put 4 and 5 on here. And when I graph it, it's going to be, since it's equal to, closed circle at 4 this time. And 5 is not equal, so open circle. And if x is, this is really saying x is in between 4 and 5. So there's my final answer, graphed. Okay, so there we go. Looking at example C. Now this is an or statement, so remember that it's just we have to graph wherever either one is true. So for C, we just solve each one individually like we have done in the past, and then we'll graph it. So subtract 5, so x is less than or equal to 2, or x is greater than 8. So let's graph this. Here's 2, here's 8. So x is less than or equal to 2, so equal to, so it's closed, filled in circle, and to be less than to the left. Okay, so there's that shaded, and then x is greater than 8, so it's not equal to, so open circle. To be greater than 8, you know, numbers 9, 10, 11, those are all greater than 8. They're over here. Okay, so there is my answer for C. We're going to go ahead and just move into absolute value equations. So if you have any questions on how to solve these compound inequalities, please make sure you write them down. And if you want to, you can pause the video and take a little break. Otherwise, we're going to go ahead and move on to absolute values. Okay. So absolute value of a number is the distance, remember, from 0 to that number. So the distance from 0 to 7 would just be 7. Okay, remember this, the distance from 0 to negative 2 is 2. So it's basically always just taking the positive value. So some things we want to remember is what could x equal? Well, what would give me an absolute value of 3? Well, obviously 3, and the absolute value of negative 3 is also 3. So for this problem, my answer would be 3 and negative 3. Okay, so let's keep that in mind as we move into D. Okay, looking at D, really what this is we're going to have our solution just like as is. So we know we have to graph that x is less than 4. Okay, but x is also, okay, now we're going to say the other option is negative 4. So it kind of makes sense that if I'm changing it from a positive to a negative, what do you guys think is going to happen with the sign? The sign is going to flip. So these are really my two solutions to my inequality with an absolute value. So let's go ahead and graph those. Okay, and it's when they're both true, so it's an and statement. So x is less than 4, but greater than negative 4. So going above 4, open circle. To be less than 4, be to the left. X is greater than negative 4, so once again, open circle, going to the right. So as you can see, my solution would be open circles, and it's double shaded in between here. So there is my answer graphed. I'm going to write it as a compound inequality, so it's really negative 4. If I flip the sign around, less than x is less than 4. So there that is graphed. Okay, so there's our first absolute value equation. Let's go ahead and look at E. Now, in this case, we have the absolute value of, we already did D, so sorry, I don't know why that's on there. We're going to do E. Okay, so in this case, we had an and statement. And our final solution was that negative 4 was less than x is less than 4. Now, if you notice, we're starting with a greater than statement. This one's actually going to be an or statement. So when you start with a greater than, It's going to be an or. So in this case, x is greater than 4, or x is less than negative 4 when we flip that sign around. Okay, so there's my solution. And then let's go ahead and graph this solution. Okay, let's graph this. So we have negative 4 and 4. So x is greater than 4. So open circle, to be greater than, I'm going to the right. X is less than negative 4. Open circle, going to the left. So this would be my solution graphed here. Okay, and here's some little tips to help you remember. Okay, if it's a less than, think about less than equals and I think, than kind of sounds like and. So less than, if you have a less than or equal to sign, it's going to be an and statement. Here's the easier part. Greater than, greater, I think about it, is an or statement. Okay, so the greater is that it's a greater statement, so it's an or statement, and so it's going to be an or, and less than is an and statement. Okay, so we have some examples here, and I just kind of gave you my little hint here. So example 1, we want to go ahead, sorry, it's not an example, it's just part of our description for us to remember. So if it's a less than, it's once again showing us that this is an and statement. If it's a greater than, it's an or statement. Okay, so let's go ahead and look at example 2a then. Okay, so right away I would look, is this a less than or a greater than sign? This is a greater than sign, so this is going to be an or statement. Okay, because it's a greater. So what I would do is take each piece and solve it. Okay, so the first one is going to be that 3x minus 12 is greater than or equal to 6. So I set it up the usual way. And then my other is going to be 3x minus 12, and I flip my sign, is less than or equal to negative 6. Okay, and I would solve. I would add 12. So I have 3x is greater than or equal to 18. Divide by 3, and so x is greater than or equal to 6. Then I would go ahead. On my other one, I would add 12. I have 3x is less than or equal to 6. Divide by 3 on both sides, so I have x is less than or equal to 2. So these are my statements. It's a greater than, so it's an or statement. So here is my solution algebraically. Now we need to go ahead and graph it. We have 2 and 6. X is greater than or equal to 6, so it's going to be filled in circle at 6, and then to be greater than, I'm going to the right. X is less than or equal to 2, so once again, filled in and going to the left. All right, so there is my answer for example 2A. Let's go ahead and look at 2B. Sorry, I'm just going to throw this on another slide here so it's easier to see. So why don't you guys pause the video and do B right now, and then come on back and we will finish this one. Okay, hopefully you've had a chance to do this problem. So when I look at this one, I notice it's a less than sign. So this one is going to be an and statement. Okay, so I know I will have 3x plus 4 is less than 10, I will solve, and I will have 3x plus 4 is, I flip it around, greater than negative 10, and change that sign on there. Then I would solve, so subtract 4 and divide by 3. So x is less than 2. Here I would subtract 4. I would have 3x is greater than negative 14. Divide by 3, so I'd have negative 14 over 3. This is the same as negative 4 2/3. Okay, so it's an and statement. So I'm going to write my final answer as a compound inequality. So this is less than x, and then x is less than 2. So it's negative 4 2/3 is less than x is less than 2. So there's my answer written as a compound inequality. And then I want to go ahead and graph it. I'm going to graph it up here. So I'm just going to say negative 5. Negative 3. All right, there it is. So at -4 2/3, that will be approximately here. It's an open circle. And I'm going to be going all the way to 2. So I shade in between. And there is my answer for 2B. Okay. Let's go ahead and look at our final example. To prepare for a job interview, Megan researches the position's requirements and pay. She discovers that the average starting salary for the position is $38,500, but her actual starting salary could differ from the average by as much as $2,450. A says write an absolute value inequality to describe the situation. Let X equal Megan's starting salary. Okay. Well, what it's saying is Megan's starting salary could go plus or minus $250,000. So Megan's starting salary is X. And if we want to know how far away her actual salary is from $38,000, I'm going to subtract $38,500. Okay, so this will tell me how far away her salary is away from that, and it's going to be could differ as much, but it's not going to be any bigger. So this has to be less than or equal to $2,450. So let's just say, for instance, Megan's salary was $40,000. You'd plug in $40,000, so $40,000 minus $38,500 would give me $1,500, and then that'd be less than or equal to $2,450. So that would be an example. So this would be my equation. Now B says, solve the inequality to find the range of Megan's starting salary. So we're going to solve it. Most of you could probably think, well, why don't I just take it and add 2,450 and subtract? But we're going to do it using the inequality. Okay, so as we did before, just solve it as the regular. X minus $38,500 is less than or equal to $2,450. And our other answer is X minus, flip the sign around, change to a negative, and solve. So I would add, so X is less than or equal to, when I add this, I get 40,950. And if I add it to here, I get X is greater than or equal to negative 2,450 plus 38,500 will give me 36,050. Okay, so this is the range her salary could be in. If you notice, X is greater than 36,000 and X is less than 40,000, or almost 41. Okay, so to write this out, the final answer would be her range could be as low as $36,050, or her salary could be as high as $40,950. And that would be my solution to the equation. Okay, that's going to be it for the section Unit 1, Notes 4. So if you have any questions, please write them down. Otherwise, next thing you'll do is the practice worksheet. So have a good day. Bye.